Yeah, guys, we'll start with this topic today. uh, so here I'm just going to explain, okay, some of the points regarding collections first, some of the methods. Then we'll start with the programming and collections. Okay, let's start with this document. Uh, Yesterday I told about how do we work with generics in Java. So today we are going to discuss about we are going to start with the concept called as collection framework. Okay, so we are going to start with the collection framework, and there are many things to discuss in collection. So first, I'll just talk about these points, whatever I've written here, and after that, then I will start working. I will start explaining about the one by one class in collections. Okay, we'll start with that. We'll start with this topic. So, actually, a data structures is a concept, and basically the purpose of this concept is to well organize the data. Nothing but efficiently we want to organize the data based on a principle. So in order to organize the data efficiently based on a principle, we have a concept called as data structures. And why we need to, I'll give an example in understanding about what is the meaning of organizing the data efficiently based on a principle. Okay. I'll start with that point. Okay, let's go ahead now. So uh, data structures is a concept which is used to organize the data efficiently. So what is the use of organizing the data based on a principle is you can search for the data, and you can sort the data, and you can retrieve the data. So these are all going to become an easy process. And to understand my first point of what I written here, data structures is a concept which is used to organize the data efficiently based on a principle, so that searching for the data, sorting the data, retrieving the data, these are all going to become easy and fast. So to understand my first point, what I have written here, uh, let's take for example, uh, okay, see, uh, while we are going to school, for example, while we are going to school, we are going to arrange our notebooks, or it could be the textbooks also. Generally, we are going to arrange our notebooks into our bag based on a principle. That is, principle is here timetable. See, for example, Monday, this is the first period, and second period will be, for example, first period will be an English period, and then next period will be a math period, then science period, okay, then biology period. Like that, we have a timetable. So generally, what we do is we are also going to keep our notebooks in the same order into our school bag. So what happens now? Once, for example, if that period is over, then generally what we do is we are going to keep that notebook at the back side of that order. So like that, generally what the point is now, why we are organizing our notebooks based on the timetable principle. Yeah, timetable is a principle and our notebooks is the data. So in a school bag, we are arranging our notebooks on a timetable principle. Okay. So the reason why we are doing like that is what we can search for the notebook faster, right? And we can retrieve the notebook faster from the bag if you arrange the data like that. The same concept is called as data searches. So this is the basically I can say a simple example to clearly get an idea of what is a data searches. Okay. So I think uh, you people got my point. You people got my point, like what I'm trying to explain here. Am I clear with this? Am I clear with this? Did you get this? Did you get this right? Okay. So principle here timetable is a principle, and based on the timetable principle, we are trying to organize our data. I mean nothing but we are going to organize our notebooks, our textbooks or our notebooks, so that in a bag we can search for the notebook, and even we can sort the books, and also we can retrieve the books very faster. So that's how data structures concept also works, right? And we already know arrays concept, right? And if you know arrays, even we call array is also one data structure, because in array also the elements are organized based on what index. First element has index 0, the second element is index 1, so that we can retrieve the element faster from array. Suppose I want to retrieve the third element of array. So how can I retrieve the third element of an array? By using its index. Am I correct? By using its index, right? So array is also one data structure. It will organize the data based on the index. Okay, so we know already array. So that's why you got already the name of the concept of data structure first of all, right? So there are different principles are available to organize the data. One principle is like last in first out. Different principles are there. Let's say LIFO principle. LIFO is one principle, last in first out. And there is one more principle, FIFO, which is called first in first out. Linked list is also one principle to organize the data. Tree is also one principle to organize the data, tree structure, graph structure. Okay, so these are all the different principles. These are all the different principles that are available to organize the data, efficiently. Okay, so if you go back to the programming language like C++, there what happens is, to implement the principle, for example, last in first out principle, or first in first out principle, or a linked list principle. For example, if you want to implement these principles to organize your data, you have to write your own programs. You have to write your own programs. But whereas when you come to the programming of Java, there is a concept given called as collection framework. So in Java, we got predefined classes. and also of course interfaces. Okay, so we got some predefined classes and interfaces given by Java, and those classes and interfaces are given by Java based on these principles only. Last in first out principle, or first in first out principle, or linked list principle, or a tree or a graph principle, like that. That's why in Java we no need of writing our own classes. Instead of that, we can directly use the classes and we can organize our data, right? So that is the difference you can find between the C++ programming and as well as Java programming. Okay, so that is what in Java we are calling these classes and interfaces together is called as collection framework. Okay, so collection framework is basically, it is a set of or a group of classes and interfaces, and those class and interfaces are created based on the principles of data structures like LIFO principle or FIFO principle or linked list principle or a tree or a graph principle. Okay, so basically what is collection framework means? Collection framework is a group of predefined classes and interfaces, and those class interfaces are given by Java. It's a predefined set of class interfaces, and those class interfaces are created by implementing the principles of data structures like either last in first out principle or first in first out principle or linked list principle, etc. Okay, right? Last in first out, the best example is for example, if you take MS Word, for example, I have changed the color of this particular statement, for example. So this is the last action what I did is changing the color of this statement. This is the last action I did. Now, the first I want to reverse now. When I'm reversing my operations, whatever I done, what happens on the first operation to be reversed is changing the color of it. This is called undo operation. For example, if I say Control Z, then what will happen now? Undo operation will execute. What undo will do now? Undo will cancel this operation now. Nothing but what the last operation I did, what the last instruction I executed, that is going to be first instruction to be come out. So undo operation is the best example for what? LIFO principle. If I say Control Z, then tell me again the color is change it back, which is called last in first out, which means whatever the last data item entered into the collection will be the first data item will come out of the collection. That is called as which principle, guys? Which is called LIFO principle, last in first out principle. And first in first out principle is there are multiple. For example, in a shopping mall, you are waiting in a queue for paying the bill, right? To pay the bill, you are just you are waiting in a queue, right? So whoever is first in the queue will be the first person will come out of the queue. That is called first in first out. So okay, first in first out. So that is also one principle. LIFO principle, FIFO principle, linked list principle. For example, you are visiting some pages in the browser. You know, browser has a back button and forward button. If you click on the back button, whatever the previous page that you visited, you can go to that page again. If you click on the forward button, you can go to the next page. Once you visited multiple pages, generally what you have in the browser, in the history of the browser history contains what? Back button and forward button. Back button is to come back to the previous page, forward button is to go to the next page. This is called as linked list. It's an example for linked list now. So the pages are got linked in the browser history so that you can move either to the back page or to the front page or to the next page. So that is what actually called as a linked list. So these are all different principles basically. LIFO principle, undo operation is a good example. FIFO principle, printer queue of jobs is good example. For example, at a time I am telling the printer that print this, print that, print that. Okay, for example, I'm telling the printer, for example, I'm sending a request to the printer saying that what, print these 50 pages. Next, immediately I'm sending one more job saying that print these 10 pages. Next, I'm saying that print these 45 pages. There are three printer jobs are available. But how does the printer will work? The printer is first going to take up the first job, then followed by second job, then followed by third job. First in, first out. It will do the first job first, second job next, third job last. This is called as first in, first out. And similarly, we have something called as linked list principle. And just now I told you the browser history is a good example for linked list principle. Okay, so basically the difference between Java programming to other programming is what, in other programming we have to write our own programs. Like for example, you go to C++, but when you go to Java, .NET, or even if you go to the programming of Python, so what happens in all these things? You no need to implement your own programs to you no need to write your own programs to implement these principles to organize the data. Already predefined classes are available and given by the programming language, and you are supposed to use them, and you can use them directly, and you can able to work with the data structures. So that is the advantage of the programming languages like Java or .NET or Python, because they have predefined collections. Okay, that's an advantage. And what the advantage of collections is, with the help of collections, we can store elements, and we can able to perform operations like searching for the elements, or sorting the data items, or retrieving the required data items in a faster way, in a easy approach and a faster approach. That's the advantage of working with the collections, right? So collections is basically for grouping what we can say objects together into a single object. We can group multiple objects together into a single object, and so that even we can able to transfer this group of objects at a time with the help of a collection object, or we can able to search for the element, or we can able to sort them, or even we can retrieve the element very faster. So to make searching, sorting, or retrieval of the objects faster, we need one more object, that is called collection object. So a collection is a group of objects. Basically, if you want to tell the definition in general, in a layman terms, we can say something like a collection is an object which contains internally a group of objects, or it stores group of objects. Like how array is storing elements, the collection object also stores elements, but here the elements are objects. That's what I'll actually call as a collection object in terms. Okay. Now from here, first I will explain the hierarchy of the interfaces and classes in the collection framework, and then we will look at about some of the common methods. First we'll go with the list interface, then we'll go with the set interface, then we'll go with the queue interface. And whatever that I'm explaining here, I mean whatever the hierarchy I'm explaining here, we are just going to look at about the programming based on those interfaces as well. Okay, so here I've drawn one diagram, okay, because again writing this diagram in the class will take some time. That's why I have drawn the diagram. Just I would like to show you to directly. So there is one interface called as iterable. Iterable is the interface which we can call it as a base interface. And from iterable, we have something called as collection interface. These are all interfaces. You can see in this total diagram, you are finding some classes. You can see there are some classes here. And at the same time, you are also finding some interfaces. All these classes and interfaces are given by Java. Okay. And all these classes interfaces is commonly called as collection framework. They are called as collection framework. Okay. And these classes and interfaces which are created by Java, they follow data structure principles. Like some of classes will follow last in first out principle. Some classes will follow first in first out principle. Some classes will follow index principle. Some classes will follow linked list principle, like that. But finally, all these classes and interfaces, whatever is there in this diagram, they follow, all these class interfaces will follow the principles, data structure principles for organizing the data. For organizing the data. So the first interface is called iterable. This is an interface actually. Iterable is an interface. Collection is another interface. Collection interface extends iterable. Collection interface extends iterable interface. I repeat once again. Collection interface extends what? Iterable interface. Iterable is the base. Actually, we most of the times refer collection interface, but feel that collection interface also extends another interface called as iterable. And in my diagram, if you are finding an arrow like this, its meaning is it extends. And if you are finding an arrow with a dotted arrow, that is called implements. So suppose if you take collection and iterable, this is called interface to interface. We can say the parent interface is iterable, child interface is collection. So we are going to use extends because interface can extend interface. Class can extend class, interface can extend interface. So the arrow is extends arrow between collection and iterable. Okay, but for us, this interface important. Collection interface is important. We don't talk about iterable. We only talk about collection. So we feel that collection is the important and base interface for all our collection programming or for our collection framework. And remember, collection is an interface because later on we are going to see a class called as collections. If I add yes, it becomes a class. That class is also there in Java. Collections class is given, which is a utility class. We'll discuss about that in further. But remember, collection is an interface. Later on, you will find collections, that is a class. That class we'll discuss later. But currently, we are only looking at collection interface. The people feel that collection interface is the important interface in collection framework, the base interface. Actually, collection interface also has one more base interface, that is iterable. But we talk very less on iterable, but we talk more on collection. Now, from collection, there are three interfaces are what we can say extended. Collection interfaces, three child interfaces. For example, you take list. I have written here already, whether it's interface or class, you can see with the help of these notes. List is an interface. Set is also another interface. Queue is also another interface. So basically, these three interfaces and this hierarchy should be there in your mind at the time of writing the programs and discussion. This diagram will play this particular diagram will play a key role. List is an interface. Set is one more interface. Queue is another interface. These three are the interfaces, and these three interfaces are extended from the collection. So we can say collection is the parent interface, and list, set, and queue are the child interfaces. Okay, list, set, and queue, all these are child interfaces, and the parent is collection. That's why most of the times we are going to discuss with collection, but not with iterable. Okay, collection has a parent called iterable, that we don't talk much. but we only talk about collection interface, list interface, set interface, and queue interface. Queue interface. Okay. When you come to the next level of hierarchy, I repeat. Next, I'll add the data on top. Yeah. When come to the list interface, it has a class called as array list, and it has another class called as linked list, and even we have one more class called as vector. So what are these array list, linked list, and vector? These are the classes. List is an interface. List is an interface. Array list, linked list, vector, what are these three? Are the classes. You know, class extends interface or class implements interface? That's a question. Whenever you write a class, whether class extends interface or class implements interface, that's a question. Okay, definitely class implements interface, right? Class doesn't extend interface. Class will implement an interface. That's why I'm using this dotted arrow, and I've given here the legend. Dotted arrow indicates implements and the arrow indicates extends. Okay, observe here. Linked list is a class. It's a class. Array list is a class. Linked list is a class. Vector is a class. All these three classes are from which interface? List interface. Stack is a class. Stack is also a class. Stack class extends which class? Vector. Because these two are classes, class to class is extends, no? Class to class is extends. Interface to interface is also class to class is extends. Interface to interface also extends only. But whereas class to interface is implements. Implements. So what are the implementation classes of list interface? What are the implementations of list interface? Array list is one implementation. Linked list is another implementation. Vector is another implementation. Okay, right? So for vector, there is a child class. Who is the child class of vector? Stack. So this hierarchy is a basically very important hierarchy that you must know about it. So, okay. So basically, what I'm trying to say now, guys, there is a class called as stack. Stack is a class which extends vector. Am I clear with this? Stack is a class which extends vector. Vector is a class which implements list. Array list, linked list, vector, all these three are
classes.
The classes, they are called implementation classes. They are the implementation classes of which interface? List. Now coming to set. We'll understand how can we differentiate a list and set, or how can we differentiate a list and queue, and how can we differentiate set and a queue. Right, okay, that we'll discuss later. But presently, collection interface has, okay, three types. What are the three types of collections? List, set, and queue. People call the wording like this. In Java, collections are three types. What are the three types of collections? List is one type of collection. Set is another type of collection. Queue is also other type of collection. Actually, apart from these three, there is one more separate type of collection also available in Java, that is called map. That is called map. So what are the collection types in Java? In Java, there are four collection types are there. What are the four collection types? List, set, queue, and map. Map we will discuss next, because map is a separate collection. I mean, it's a collection of key value pairs of data that we'll discuss later. So currently we are discussing three first. What are the three? List, set, and queue. Okay, coming to set interface. Coming to the set interface, there is a class called as what? Hash set. Okay, hash set is a class, and hash set class implements set interface. Linked hash set class extends hash set class, because that's why I know that you people get confused, that you are definitely going to get confusion, which is extending, which is implementing. That's why first identify, if there is an arrow like this, it is called extends. If there is an arrow like this, it is called implements. And basically, you know, if it is a class to class, or if it is an interface to interface, it is going to be extends. If there is a class to interface, it is going to be implements. Class to class is extends, interface to interface is extends, class to interface is implements. Right? If you look at the arrow here, it is from where to where? This arrow, if you take, it is class to interface. Class to interface is implements. This is, if you look at this arrow here, this arrow where my mouse is moving there, moving around, this is called class to class. Class to class is what? Extends. There is a class called as linked hash set. Linked hash set class extends hash set. Everybody should have this entire diagram in your mind. If at midnight also, if somebody asks about who is a base class or parent class of linked hash set, means immediately you have to say answer hash set. Okay, immediately you have to say answer hash set. Like that, this diagram should be there in your mind. This is a very important mind diagram that you people need to keep it in your mind. Okay, you have to take a photo of this into your mind. So linked list, linked hash set is a class which extends hash set. Hash set is a class which implements set interface. Now coming to sorted set. Sorted set is an interface. So tell me, this arrow is now interface to interface. Interface to interface is called what?
Extends.
Interface to interface is called extends. Interface to interface is extends. Okay, class to class is also extends. But whereas class to interface is called implements. Okay, tell me, what is sorted set? It is an interface. Sorted set is an interface. Set is also an interface. So interface to interface is extends. Navigable set is also one interface. This interface extends
Sorted set.
sorted set. So navigable set extends what? Sorted set. Sorted set extends what? Set. What are these three?
Interface.
These three are interfaces. Who given all these classes and interfaces which are there in this diagram? Java. Java. Are you writing these classes by yourself? No. We are directly using them to organize our data. What about C language or C++ language? You have to write our own programs by following or implementing these principles to organize our data. But whereas in Java, we have already interfaces and also classes. Directly we can use them and we can organize our data. Okay, right. Navigable set is interface extends sorted set. Sorted set is an interface extends set. Tree set is a class.
Yeah.
This class implements
Navigable.
Navigable set. Read it properly. Navigable set. Okay, it is an interface. Tree set is a class. Class to interface is implements. Interface to interface is extends. Class to interface is implements. Class to class is extends. So class to class is extends. Interface to interface is
Extends.
interface to interface is extends. Class to interface is implements. Class to interface is implements. Okay, this is a tree set. Tree set is a class implements. Navigable set. Okay, next. Coming to the last one in the hierarchy. What's the next interface? What's the next type of collection in Java? Queue. Okay, totally broadly we can say that if you categorize in Java, there are 4 types of collections. What are 4 types? list, set, queue, and map. But map is not there in this diagram because map is a separate type of collection given in Java. That is a separate collection given in Java that is to maintain the data or to store the data in key and value pairs format. That we'll discuss next. Okay, now coming to what? Queue here. Queue is an interface. Queue interface extends collection. Because interface is what? Extends. So priority queue is what? Priority queue is a priority queue is a class. This class priority queue is a class. This class implements interface. What's the interface name? Queue. Queue. Very good. Next, blocking queue is there. Blocking queue is what? Interface. Interface to interface is what? Extends. So blocking queue extends queue. Queue. Obviously, queue interface extends collection. Okay. For blocking queue, there are two implementation classes. What are the? Of course, many are there, but important class names only I have written here. Okay. So, what are the two implementation classes of blocking queue? Array blocking queue, priority blocking queue. Array blocking queue and priority blocking queue. Priority blocking queue. What is priority blocking queue?
It's a class.
Priority blocking queue is a priority blocking queue is a
Class.
It is a class. Am I clear? It is a class. This class implements
Blocking queue interface.
Blocking queue interface. Okay. Do one thing. This diagram is very important. This diagram you have to keep it in mind, guys. Then only we can discuss the collections properly. Otherwise, you will get a doubt whether it is a class or whether it is an interface. Every time, every day, every example will give you a confusion. That's why this diagram should be there in our mind properly. Okay. Just watch this diagram and try to understand who are the classes and who are the interfaces. Please try to understand once again. I'll give you 2-3 minutes of time. For the next 5 minutes, I'm not explaining anything. I'll simply sit quiet. Please go through this diagram by yourself and try to identify the diagram first.
List.
Okay, guys. So basically, I think you have gone through this particular diagram, and this is the very important diagram, so that whenever we discuss about array list, you should not get any confusion that whether it is a class or whether it is an interface. Okay. Again, you should not get any such type of confusions. So that's why I am just asking you people that please go through this diagram, and this diagram is very important, so that you should never get any confusion like whether it is a class or interface. Okay, good. So here, out of these three types of collections, first our target is to know about list interface. Okay, I repeat once again, we are actually going to look at about a list interface. Means we are going to look at about, first of all, how can we able to work and use this list interface in our Java program or in our applications. And list is also a most popularly used collection in Java, whereas even in the real-time applications also, right? For example, I have 100 employees. Then I want to send all these 100 employees from, for example, in my application from one place to other place. Okay, I want to send 100 employees from one place to other place. For example, I want to send 100 employees data from, I have 100 employees and I want to send them to the front end, to the Angular application or React application, whatever it is. So how can I able to send them? I want to send 100 employees at a time, not one employee at a time. How can I send them? I can store them in a collection. I can store them in a list. I can store the employees into a list. That list I can send. So list is a collection. Collection can store elements. Here elements are nothing but they are objects. So collection has objects. Collection can store objects. Elements of a collection are objects. Okay. For example, you take array. Elements of an array can be primitive values also. For example, if you create int array, which is nothing but the array contains all integer values. They are called array elements. The array elements are primitive values, but whereas in collection they are all objects, which means basically, for example, if you look collection like this, a collection is one object. For example, I want to say that this is one collection object, and for example, this is all for example. For example, this is one list object, and this list object is containing, it stores, collection is one object which can store a group of other objects. For example, I am calling this as a list. So this is one object. This is one list. It is one object. A list is a collection object. But what this object contains? Elements. The elements in this collection are objects. Elements of a collection are always objects. Let's say, for example, this is for understanding, I'm writing a diagram like this. For example, this is one employee object. This is one more employee object. This is one more object. This is one more object. And this is one more object. For example, this is employee one object, E1 object. For example, this is second employee object, E2. Let's say, for example, this is third object, employee object, E3. Let's say this is E4. Let's say this is E5, something like this. So basically, this is what a collection object. This total object is called one. This total is called one collection object. What are these What are these E1, E2, E3, E4, E5? These are all called elements. What are these? These are not primitive values. What is E1? It is one employee object. What is E2? It is another employee object. Nothing but a collection is a group of
Elements.
collection is a group of objects. A collection is a group of objects. That's what I'm saying. This is what entirely called one collection. A collection is a group of objects. Okay. What are E1, E2, E3? These are called elements. Each element is also what? Object. So E1, E2, E3, E4, E5, these are all objects. So what is the purpose of a collection is, in a collection, we can store group of objects. And okay, we can search for the object easily, or we can sort these objects. We can organize the data so that we can search for the data. Data means here object. We can search for the object, we can sort the objects, we can retrieve the objects easily. To store, to store, to search, to sort, to retrieve, and to transfer a group of objects, we are going to use what? Collection. Here the collection object I take, for example, as a list object. It could be another object. What? It could be the set object, or it could be the queue object. Based on our requirement, we are going to choose one of them. Either list object to store the elements, or set object to store the elements, or queue object to store the elements. Okay. Based on the requirement, we have to use appropriate collection object, either list object or a set object or a queue object. Okay. Right. So what is collection? A collection is a group of objects which are called elements. Okay, right? And with a collection or by using collection, we can store the elements, we can search for the elements, we can sort the elements, we can retrieve the elements, or even we can transfer the elements. See, for example, how can we transfer in the real time? In the real time, we have the application with layers. Like, for example, this is the data access layer. This is the data access layer. DAL I am writing. Data access layer means this layer is purely going to read the records from the database or store the records into the database. It will perform all such operations. And in front of this layer, there is a SL, service layer. Okay. Now this data access layer, it wants to send how many employees to service layer, how many objects it wants to send to the service layer. Let's say 100 objects. Let's say 100 objects. Tell me, this data access layer wants to transfer how many objects to service layer? 100 objects. Okay. Application contains layers. Presentation layer, that's what you are using: HTML, CSS, Bootstrap, Angular, React. By using them, what type of layer you are creating? Front end. Front end is a presentation layer. Like that, we have one more layer called service layer, another layer called data access layer. Like that, application development will be done in a layer architecture. It's called layered architecture. Okay, applications are always developed in a layered architecture. Okay, so while developing the application, we create some service layer related functionalities. Data access layer. Data access layer purely talks about database. This layer will only concentrate on storing, retrieving the data from database. This layer is called data access layer. Tell me, this layer has how many objects now? 100 objects. It want to transfer these 100 objects at a time to these 100 objects. It wants to send them to which layer? Service layer. It want to send them to service layer. Okay, it want to send them to the service layer. So how can this data access layer can send 100 objects at a time to the service layer? For that, this data access layer will store all these 100 objects in a it will store them in a collection. For example, it is storing these 100 objects in a list. Then this layer will send this list to the which layer? Service layer. Service layer. Who is list here? List is a collection object. List is a collection object. What this list is a collection. It's a collection object. Tell me what this collection object has. It stores group of objects. How many objects here?
100 objects.
Right. So tell me it is transferring them to which layer now? Service layer. For example, I took like this now. So tell me collection is a group of objects. Collection is a group of objects, and it can store the objects or elements, which are called elements. It can store the elements. We can search for the element. We can sort the elements. We can retrieve the elements, or even we can transfer the elements. So how can you send a group of 100 objects at once, at a time, from one layer to other layer? By using collection object. It could be the list object, or it could be the set object, or it could be the queue object. It doesn't matter. But you need what type of object? Collection object. Collection object. So am I good with this so far?
Yeah.
Next, this diagram is very important first. Now, first we will focus on what type of collection. First, we will focus on what type of collection? List
interface.
We'll focus on list. After completing this array list, linked list, and this vector stack, then we will go to the next hierarchy, set. But first, our concentration is on list. But something, for all these list, set, and queue, these are the three types of collections we are discussing now. Okay.
Yes.
I told in Java there is a fourth type of collection also given, which is called map. That map we will discuss later. But first we are discussing what? Three. What are they? List, set, and what? Queue. But who is the base or parent interface of these three? Collection. We'll see. What are the collection methods? What are the methods given in collection? If you know these methods, then tell me these methods of collection interface are inherited to what?
List is the queue.
Because the parent, now, as you know that parent class methods are inherited to the child class. Similarly, parent interface methods are also inherited to the child interface.
Yes.
Right? Then tell me these collection interface methods are inherited to what? List, set, and queue. Which means first we look at about what are the common methods of collection interface. So these are common methods for list, set, and queue. Okay, good, because it is a parent interface. So parent interface methods are inherited to the child interfaces. So who is a child interface here? List. Another child interface is set. One more child interface is queue. Okay. Tell me. I am talking about methods of which interface now? Collection. Methods of collection interface. Methods of which interface now? Collection. Collection. Okay, so there are many other methods are there, approximately 2-3 other methods also you can find, but I have written here 9 methods which are enough. Okay, understand here. Tell me these 9 methods, whatever I have written here, tell me these 9 methods are applicable for, I mean, these 9 methods are inherited to list interface only, or other interfaces also?
Other interfaces
All
are
other
also.
Who are the other? Set
List
and
set
queue.
the queue.
So totally these are the common methods of what and what? These are the
List,
common
set,
methods for list, set and queue.
queue.
And queue. Okay, so these are the 3 types of collections, right? Set, list, set and queue. List interface, set interface, queue interface. Okay, cool. What's the first method? There is a method called add. Add. Okay, what is the use of this method?
Add the element of the
Element to the collection. If added successfully, then what this method returns?
true.
Otherwise returns
False.
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 Which means what? If this method returns false, indicates what? The element is not
Added.
Added properly.
element is not added to the collection.
Collection.
Element is not added to that collection. Okay, for example, you are using the collection type as list. You are calling add method, but you are
Yes.
getting result false. What does it mean?
It means we
It is not
cannot
added
add.
to
Added to the list.
element.
Element is not
Not
added to
added.
the list. True means
Added.
It's all added.
added to the list. Similarly, if you are working with a set object, collection type set, then what happens if the add
Element
method
is-
returns false? Element is not added to the set. Element is
Not added.
not added to the set. And for example, returns true, then element is added to the set.
Added.
So there is a method called what, guys? Add. Next one is add all. What it will do? Adds all the elements of the specified collection to this collection. What does it mean? For example, I have 2 collections are there. For example, list 1 and list 2. What and what are there? List 1 and
List.
list 2. List 1 and list 2 are the 2 list objects. List 1 already has 10 elements. Here elements are nothing but what? Objects. Elements are nothing but what? Objects.
Okay.
Okay. List 1 has how many elements?
10.
10 elements, which means 10 objects. I want to add all of them to list 2.
Yes.
I want to add all of them to list 2. Tell me, how can I add these
By
elements
using
of
a-
list 1 to the list 2? Add
By
all.
using
For example, if I start calling add method, how many elements are there? 10 elements. How many times I have to call add method? 10
10
times.
times.
But if I call add all in
One
one
time.
in one time, I can at a time I can add in single call. That's what add all. Okay, add all. So there is a method called what? Clear. What's the purpose of clear? Removes all the elements from this collection. So how can I clear the? How can I remove all the elements from my list or set or queue at a time? Clear method. If I say list dot clear, what will happen?
The
All
entire
the elements of the list are removed at a time. That's what clear. But how to remove particular element only?
using
Remove.
Remove method. What's the difference between clear and remove?
Clear.
Clear
It
will-
means all element of
Only
the
the
collection
specific
will be clear.
But
remove
clear will
the
remove all the elements. And if it is removed successfully, returns true. Otherwise, returns false. Okay. These are all the methods which are important. What's the next method we are discussing? That is called. Okay. What's the next method we're discussing? That is called.
contain.
Content.
Yeah. Next method is called contains. What happened? Just a minute. Up to remove, we did. Guys, tell me what's the next method I'm talking about.
Contains.
Method called as contains. What this contains method do?
It will verify
Checks
whether
whether a specified object exists in the collection or not. If exists, returns true. Otherwise, returns false. Which method? Contains. Contains. So suppose I have a list of 1000 elements. How many? 1000 elements. 1000. Let's say I have a list of 1000 employees. I have a list of 1000 employees. What is the meaning of word list of 1000 employees? Means I have a list with 1000 employee objects.
Yes.
Okay, I have a list of 1000 elements or 1000 employees. How to check whether a particular employee is there in that list or not?
By using containment.
Contains method. Okay, what the contains method returns? Boolean value, the true or false.
False.
If the element exists in the collection,
It will return true.
returns true. Otherwise, returns false. I will talk about iterator separately. I'm not explaining iterator. Sixth one I'm not explaining separately. Sixth one I'll explain separately. Sixth one I'm not explaining now. Just iterator is there. Seventh one is what? Size. Seventh one is what? Size. What size returns? Size of the collection. Size means number of elements. Okay. For example, I have a list of 1000 employees. If I say list dot size,
It
if I
will
say
return
size, what's the size of the list now? 1000. For example, I have a set of 500 employees. Set of 500 employees. What's the size of the set now? 500. 500. How? Okay. What's the method that we need to call? Size method. What it returns? Number of elements in this collection. Okay. How to check whether this collection is empty or contains any elements? Is empty. Is empty returns what? True. If the collection is empty. Otherwise returns false. For example, I have a empty list object. Then tell me is empty if I call. Returns what? True. Because my list does not contain any elements. My list is empty. Okay. Is empty is a simple method that you people can understand. Okay. So the methods are what? There is a method called as add. There is another method called as add all. There is a method called as clear. There is a method called as remove. Just I'm changing the color so that we can recognize the method's names. There is a method called as contains. There is another method which is called iterator. There is another method called as size. There is a method called as is empty. And there is a method called as toArray. What a toArray returns? An array for this collection. Means what? We can convert a collection object into array also. How can you convert the collection object to the array object? Sorry, how can we convert the collection into an array? By calling a method. What's the method name? toArray. toArray. Suppose I have a list. List is a collection object. Set is a collection object. I have a list object or I have a set object. I want to convert into an array. Then which method I have to call? toArray. toArray. Okay. So what are these? What are these methods? What are all these? What are these 9? These are the methods. Methods of which interface? Methods of collection interface. Tell me these methods. These methods are inherited to what and what type of collections?
List is
3 types of collections we are discussing now in our diagram. What are the 3 types?
Queue.
List is one type of collection. Set is another type of collection. Queue is other type of collection. They are all called types of collections. Then tell me these methods are inherited into what type of collections now?
All collections.
Into list, into set, and also into the queue. Into the queue. Am I clear with this?
Yes.
Good to know. So far we discussed about methods of collection, and next we will start with methods of list interface. Then we will work with the array list class. Then we'll work with the linked list class. Then we will discuss about vector class. Then after that, again, next we'll move on to next branch in our tree, our hierarchy set. Okay. So first we want to complete this portion. Which portion?
List.
Portion. After this,
Set
portion. After that,
queue
portion. Are you getting my point? Okay. So that's what our intention. Currently today, what I have explained, this entire hierarchy I have explained, and also the common methods, the methods of which interface?
Collection interface.
Collection. So these methods are related to what and what type of collections?
List, set, queue.
Set and queue.
Queue.
Am I clear with this now?
Yes, sir.
Am I clear with this now? This is what for the today's session. Okay. Am I clear for today's session, guys? I'll share this document as well as yesterday's document also. I think I have not shared yesterday's document. I'll share both.